Hi everyone. Please find today's warm-up in Canvas and download it or print it so you can write on it or write on your own paper to complete it. I want you to pause this video and give it a try, and then unpause the video to check your answers. All right, so number 1 said use table B to find the critical value T star. And so hopefully you were able to do that when the sample size was 26. That makes the DF 25. So let's see, I'll use blue. We're looking at this row. And then it's asking for 98% confidence, which is here. So they match up right there at 2.485. Now with technology, we can use our calculator. We'll do second vars 4. And if this is a 98% confidence interval, the area is 0.01. The DF is 25, and then we hit paste and get 2.485. Remember, we always put the positive version. So those are the same. But I do want to show you for letter B a 99% interval with SRS of 85. So when I use table A on this, table B, I'm sorry. When I use table B on this, let me erase some of this distracting stuff. Remember I said when your DF isn't on there, round down. So we're looking for DF equal to 84 because this problem is says 85 observations. So we're looking for DF equal to 84, which I don't see on here. It's either 80 or 100. And so we'll always round down to 80. And then this was 99%. So 80 right here is the one that we'll use, 99%. And so that's 2.639 is where I got that. So if you do use we call it the conservative DF when we round down like that. So when you do use that, just make sure you write what the DF is. Oops, and I wrote from table A. I knew I had seen that. There we go. Table B, my bad. Make sure you indicate that you used that DF. Now with the calculator, we can get the more exact version. So again, we would do second vars 4. This time I'm going to put 0.005. Remember, it's 1% left over in both tails and then cut that in half. You can always do also 0.01 over 2 like this. Your calculator is smart enough to know what that is. And then this DF would be 84. So we can put the exact DF in the calculator and we get 2.636. So I wrote that here. And they're very close. The more exact one will always be a little bit higher. Lower. And so using the larger T-star is called more conservative, using the smaller sample with the larger T-star because it gives you a larger margin of error. And if you're estimating, you would rather have a wider margin of error to be more likely to be correct with. Okay, now a couple things though. I do actually want to explain while I'm talking to you a little bit more about DF, degrees of freedom. If we were in class, I like to demonstrate this I put 5 chairs in the front of the room. So then I'll call on 5 different people and I'll call on 5 people one at a time. So I call on the first person, I say, pick any chair. And they have 5 choices. They get to choose any chair they want. They get to sit down. Call on the next person, I say, pick any chair. They sit down. There's 4 choices left. Call the next person, pick any chair. They sit down. And then basically what happens is when I call the last person, I say, pick any chair, and everyone laughs because there's only one choice. There's no freedom to choose. And so having a sample of 5, there are 4 people that got to choose where to sit. So the degree of freedom for that scenario is the sample size minus 1. And that's just where it comes from. There's a lot more math behind it, but it's just a quick explanation of what the degrees of freedom is. And if we were in class, I would like to show that visual aid to help you with knowing what the degrees of freedom is and why we use that language to refer to it. Anyway, let's move on to number 2. So hopefully you guys were able to check the conditions, random, 10%, and normal. They said random sample. The 10% is really reasonable. Now the graph here is just kind of a distraction. So this is skewed to the right, but it doesn't matter because your sample size is so large that the sample distribution is irrelevant. So remember, it's okay. So it's like strongly skewed right, but it doesn't matter since n is at least 30. Then you always want to refer to the CLT when you are using the 30 rule to check it. So make sure you always keep that in there as a reference. Okay, number 3, let's talk about this one a little bit. Now with A, I had to use a Z-star, even though means always use T-stars, because if I don't have a sample size, I'm just going to assume it's infinity. Like I don't have any other way to do it. So this is n minus 1. There's no way for me to pick one of these sample sizes if I'm solving for the sample size. And so I just had to use the Z-star because I didn't have another estimate to use. And the Z-star is going to give me the largest possible sample out of the options if I were to choose different T-stars. So in my calculator, let me show you how I did this because it's a tiny bit different than one with proportions. So first, I want to divide my margin of error by the Z-star, which we've done that before. But this time I have 36 over the square root of n equals that. And so now I want to do 36 divided by the answer. That will switch the n with the answer. So now I have 23.52 equals the square root of n, and I'll square that. So now our 3 steps are to divide again, and then square. So I'll write those on the page here in red. Oops, not in that. Okay, so first we divide the margin of error by the Z-star, and we have to use Z-star because we don't have a sample size to use T-star with. Then we divide sigma by the answer, or the standard deviation. I'll just say SD so we won't get confused. By that answer. Then we square, and we always round up. So those are the steps. Now with letter B, like I said, we needed to sample 554 people to get the margin of error to be within 3. That's way too many, so they just did a sample of 15. And so here are the 15 values right there. And so the first thing I wanted you to do is just calculate the interval, just practice using the formula, not to do any of the steps. We'll practice the steps plenty, and I think you guys know those by now. So you needed to use a calculator or a staple to get the mean and standard deviation. And then the DF, we do sample size minus 1, find the T-star, and then plug everything in. I always like to write the formula first because that helps me plug it in. And then you will need to identify the DF, and the T-star so that you can plug them into the formula, get the right answer. All right, hopefully that made some sense to you guys. This one was kind of long, but all important stuff. And so let me know if you have any questions. Now let's take out the activity about the Chips Ahoy versus the chippers from Walmart. Today we want to know, is there a difference in the number of chocolate chips in Chips Ahoy cookies versus the number of chocolate chips in the Walmart brand cookies? So a lot of times people will say, oh, Chips Ahoy is better, but we want to know, is it really better or are they about the same? So we're going to be counting the number of chips in different samples of cookies. If you're at school, you can do that. And if you're at home, you'll just have to copy down some of the numbers that we have already gotten. So if I took my sample, I have some cookies in front of me, and I'm going to count the number of chips in the Chips Ahoy and the number of chips in the Walmart chippers. And then what I'm going to get is 22 and 18. So I got 22 in the Chips Ahoy, and I got 18 in the Walmart chippers. So if you're at home, you can say that you got the same thing as me. If you're at school, you'll get your own numbers. Then with number 2, find the mean number of chocolate chips for each. So we need to collect the class data. So again, at school, we'll compile it all together and create our own mean and standard deviations and our own difference. But if we're not at school, let's just go ahead and use some of the data I've had in my previous classes. And so in one class, I know we had 21.56 for the mean, 2.49 for the standard deviation. And then for the Walmart chippers, it was 18.22 and 4.51. And then both of our sample sizes were 28. We had 28 people in the class that did this when we did it before. So the difference in the means would be if I did 21.56 minus 18.22. And so that is 3.34. So what I want you guys to do now is you should be able to finish this worksheet 3 through 6 on your own using what you know from sampling distributions for the difference in two means. And so we've done that in Unit 5. You can refer back to those notes if you need to, but hopefully you'll be able to find the shape, the center, and the spread or variability for the sampling distribution of the difference in two means, and then use what you know about estimating to do the conditions, the interval, and see if we have evidence. So go ahead and pause this video, complete 3 through 6, and then you'll unpause for us to debrief and do our notes and check your understanding. Oh, right. So hopefully you were able to get the shape, the center, and the spread. If you weren't, you could always use the formula sheet right here. The shape isn't on here, but here's our center and our variability, our mean and standard deviation for two populations of means. So that's where you can find those if you weren't sure. And then we had our conditions, our interval, and number 6. But I'm going to start back at the beginning and do some notes on these. So first, remember, these are called statistics when they come from samples. So this is going to be our statistic, or another word for that is point estimate. So that's the estimate that we have to estimate the difference in the number of chips. We don't have any other ability to estimate that value besides just subtracting the sample means. Then the shape is approximately normal because the populations were normal. Which they told us in the stem, right up here. Population distributions are approximately normal. Then we have our center and our spread. Now with the spread, we did not know sigma, and we typically won't. If we don't know the sigma, this population standard deviation, then we have to estimate with the sample. But remember, we're trying to estimate the population means. So I'm going to write unknown here, and these are unknown as well. So for the spread, we're going to change the name to standard error, S of x bar 1 minus x bar 2. And it looks almost the same, except it's just S squared for sample 1 over sample 1 size, and then S squared for sample 2 over sample 2 size. You'll find that right about here on your formula sheet. So no need to memorize it. And again, we won't typically be provided with sigma and S and have to decide between them. So if you have the standard deviation from the sample, that's typically just what you'll be using. And it's called standard error now because it is an estimate of the population standard deviations. Then we have our random. The samples were random for the conditions, 10% and approximately normal. The main thing here is we need to check for both samples or slash population since we used. So make sure you do that. Notice how I did both. I had samples are random. I had population distributions are approximately normal. And so make sure you check for both on a 2-sample procedure. For number 5, I'm hoping that you were able to get that from your previous knowledge. You should be comfortable with this generic formula of a confidence interval at this point, statistic plus or minus critical value times standard error. In this case, the statistic is going to be x bar 1 minus x bar 2. Because we're using x bar and s to estimate, our critical value is a t star, and the standard error is the sample standard deviation squared for sample 1 over sample size 1 plus the standard deviation from the sample squared to sample 2 over sample size for sample 2. So there, and then let's look at this DF before we get too far. The DF, I had 2 samples, they were both size 28, so I did 28 minus 1 and got 27. I'm going to write something down called this is called the conservative DF. I don't have a lot of room here, do I? So let's just write it over here. And that's when you take your smaller sample size minus 1. In this case, both sample sizes were the same. And so 28 and 28, the smaller one is 28. So I did 28 minus 1 to use 27. And this is the interval that we got. Now, I do want to show you guys something in the calculator at this point. We haven't used the calculator to do any of these yet, but this is a good time to show you because your homework might include some of these other TFs. So I want everyone to get out your calculator and hit stat and go over to tests. And you'll see here there's a lot of options. And what we're interested in right now is just, we have 2 samples. We're doing a mean, so it's a t, and we want to do the interval. So we're going to choose 2 samp t int. Now I don't have data in my list, so I'm going to scooch over to stats. And then here we just fill in everything we know. So we're going to say sample 1 was the Chips Ahoy. That was 21.56. The standard deviation for that sample was 2.49. And our sample size was 28. X bar 2 was 18.22. So, and this is again for my class previously. It's not necessarily the class that you guys got. So if you're using your own, make sure you put your own in. And then the second sample size was also 28 for this particular case. C level, that's your confidence level. So 0.95, it's got to be a decimal. In this case, we were doing 95% interval, so 0.95. Pooled is going to be defaulted on no and leave it there. Pooled means the population standard deviations are the same, which we won't see in this class in AP stats. Basically like intro to stats, we don't see that there. Then hit calculate. So I want to show you one thing. This just gives you the interval, which is really nice, but notice that the interval is a tiny bit different than the one we got. We got 1.34 to 5.34, and this is 1.375 to 5.305. So I'm going to write that down. One is not more correct than the other. The difference between them is that degrees of freedom that you see right here. DF equals 42.061. So it's this crazy decimal. And what you'll notice is, well, that there's no way for us to figure that out on our own. It's a really complicated formula that you don't have to know, but you can let your calculator get it for you. What you would need to be careful about, though, is when you show your work, you still need to show your work. So just don't put this there. Just put the letter T star as a variable, and that way you don't have to worry about using the wrong T star, writing the wrong T star down for a different interval, because T star is not 2.052 when the answer is 1.375 to 5.305. What it is we could actually just hit second bars 4 and use this decimal 42.061 to find it if you want to. So this is a 95% interval, we'll do 0.025. And I can type 42.061 as my DF instead. And it can work with the decimal. It'll get you 2.018. So in this case, I could write T equals 2.018, and then instead of the 2.052. So if I'm confusing you, just make sure that you only write the correct T star for the interval that you got. So if you want to keep using the conservative T star, perfect. Just make sure you write down what your DF is for that. And then if you want to use the calculator, then make sure you either find the proper T star from inverse T to fill in the formula, or you just leave the letter T star blank. And then you make sure you write down the DF that you're using. That's why it's so important to include the degrees of freedom in your statistical work, because there are different ones that will get you different answers. We call this we call the smaller n-1 the conservative degrees of freedom, because the interval will be wider than when we use the official degrees of freedom as the decimal version. So notice 1.34 to 5.34 is just a little bit more wide than 1.375 to 5.305. Okay, so last thing, number 6. Let's just debrief this again. We've talked about it before, but I do want to show you kind of an easy way to remember this. All plausible values are positive according to our interval. So we do have evidence of a difference, and not only do we have evidence of a difference, we have evidence that Chips Ahoy have, on average, more chips than Walmart chippers. I'm just going to write a couple of reminders for us for that. If your interval is all positive, then you have convincing evidence. And so that means 0 not included. And it's showing that all plausible values are positive differences. If your interval is all negative, you still have convincing evidence, just of the opposite thing. Because I did, well, Chips Ahoy minus Walmart chippers. If I had an all negative interval, then that would show that Walmart chippers have more chips than Chips Ahoy. And if my interval goes from negative to positive, that means it includes 0. And so we do not have convincing evidence. Because what I'm showing is that it's plausible there's no difference, because it zeroes in there. And also, I don't have a clear sign of which direction is more, has, more weight, because it goes from negative to positive. So it could be that chippers are more, it could be that Chips Ahoy is more, and the interval does not indicate a clear direction. So that's just a quick reminder about that. Now, I want you guys to take these notes here in your important ideas box. Just very brief. We just want to make sure you know the name of the parameter, the conditions that we use to check for both samples / populations, and the formula. Now, I'm just going to make a couple of reminders about this T star. So the T star, we can use the conservative, or you can go to stat tests, and it's called 2samp T int, and then just report the DF and interval from that. And make sure you leave either find the new T star with the new DF or leave it as a variable. I just typically going to stick to the conservative for now when I show my work, but you might see in your homework some answers that are a little different based on that. All right, so pause here if you haven't already to copy all of this down, and then try to check your understanding. All right, here are the answers to the check your understanding. I will show you guys a little bit how to do this on the calculator too. So while you're looking at it, let's just go ahead and write P for our procedure and our parameter, then our A for our assumptions and conditions. Remember, I like when I have two samples, separate them so I remember to check each condition for each sample there. We have our statistical work, sorry, and our summary sentence. And so remember, I decided here to use the conservative DF. And so I was able to fill in my whole interval and get it. I am going to show you in the calculator how to get the other one just in case. So follow along here with the calculator. We're going to hit stat enter because we do have data this time. So I'll show you how to enter that in. Clear out whatever's there. And we're going to type 835,140,614,0. This time, the next one's going to be 3, -2, 4, -1, 5, 5, 1, 2, -1, and 4. Then just check over to make sure you didn't make any typos because we don't want to have any mistakes. Go to stat, tests, to samp t-test. So you can scroll up if you want. It's not that, it's like kind of equidistant. It's right in the middle. To samp t end timing. To sample interval t interval. And then this time I can click data. And so I have all of my caffeine in L1 and all of my no caffeine in L2. Just keep the frequencies at 1. This is a 95% confidence, no for pooled, hit calculate. So notice we have the mean change already listed in the table, which is really helpful because that just helps us see that we didn't make any typos. 3.2 and 2 are the same as they told us. And then we have our standard deviations, 2.6, 2.7 and 2.625. And then we have our two sample sizes. Now notice the DF is 17.986. And so if we were to use that one, what I would do, I'll use not red, I'll use orange. Okay, so what I would do is I would write, let's say if DF is 17.586, I think. Make sure one more time. Oh, 986, not 586. Then we get an interval that is a little bit narrower. So negative 1.302 to 3.7. And then what I would do instead is I would just cross out this 2.262 and write T star. Or remember, if you want to, you can actually find the T star second vars for, this is a 95%, so 0.025, and then type in the decimal version, 17.986. Oh, wow. I did not type that. 17.986. You can hit paste, and then you can use the actual T star of 2.101 right there. And so you could, like I said, just write T star or 2.101, but you cannot write 2.262 because that is not correct if you use the orange interval as your answer. So make sure you always report the DF you're using. You always use the appropriate T star or just write the letter T star so that you won't get docked for that. And then that you show all your work still somehow like this. Okay, now hopefully that makes sense. You can practice some in your homework, getting these different intervals, and then go to tutoring if you need any more additional support. Hope you guys have a great day. Thank you so much. See you next time.